This is QianqianMa from South China Botanical Garden. I'm currently an associate professor in Professor Jianguo Huang's group. Today, I would like to present our recent work on the changes in the risk of spring frost damage to European trees with climate warming. As we all know, during the active growth of plants, the frost can cause severe damage to tree growth and reproduction. This may further cause ecological and economical losses. For example, in 2007, after the eastern US frost, the economic losses for the agriculture crops was up to 112 million US dollars. And the occurrence of spring frost damage are mainly determined by two important timing. One is the timing of the spring phenological events, such as the spring budburst and flowering. And the other one is the timing of later spring frost, especially the last spring frost date, shortly LSF. The timing of phenology are mainly determined by climate factors, such as the temperature, photoperiod, and precipitation. Temperature has been identified as the primary driver, especially for temperate and boreal plants. The frosts are also determined by temperatures and also may be affected by other factors such as winds. As we all know, in the last several decades, the climate warming has been happening all over the world. Since 1970s, the warming rate was up to 0.2 degrees per decade. And this warming was not equal across the world. It's generally recognized that the warming was greater in the high latitude and high altitude area compared with other regions. How this warming will affect the spring frost damage? Early in 1985, Knell hypothesized that the climate warming may advance the spring phenology, and this may cause the increased frost damage. However, the warming may also advance the spring frost date, especially the last spring frost date. And in this way, the plants may avoid the frost better than before, and this leads to decreased frost damage. This is totally two opposite conclusions. Then how the climate warming will affect the frost damage? Since there's a very limited historical record about the frost damage, we are going to answer this question by combining the long-term phenology data and the climate data. The phenology data we used was from the Pan-European network. This network provides free access to the phenology data for hundreds of species. They collected data since 1950s. The climate data was from a graded data set with a resolution of 0.25 degrees. We defined the two indicators of the frost damage. One is the probability or the frequency of frost damage. The other one is the severity of frost damage. For the probability, we determine whether a frost occurred by comparing the phenological timing and the last spring frost data. If the phenological timing, such as budburst or flowering, is earlier than the last spring frost data, then the frost damage occurred. Otherwise, there's no frost damage. Based on this information, we use a mixed effect logistic regression model to analyze the temporal changes in the probability of frost damage. For the severity of frost damage, we checked the post-dormant minimum temperature, which is the lowest temperature after the spring phenological events, but before July 15th. The lower of this temperature, the more severe of the frost damage. Then a linear mixed effect model was applied to to check the temporal changes in the severity of frost damage. For this study, we selected 27 species. For each species, we examined the changes, the temporal changes in the phenology and last spring frost data. For each species, we only selected one spring phenol. It could be either bud burst or flowering. We only choose the earlier one. As shown in this figure, most of the dots are above the 0 line. This tells like for the majority of the species, both phenology and last spring frost date advanced. However, for any given species, the advances of these two dates are not always equal. For some species, like the first one in this plot, the phenology advanced faster than LSF, and for others, the LSF may advance faster than phenology. Now let's next we check the temporal changes in the temporal changes in the probability of the spring frost damage. As shown in this figure, each dot represents one species. The red dots show increased frost damage, while the blue one shows decreased frost damage. When we combine the changes in the probability of frost damage with phenological timing and the last spring frost, sorry, I forgot to introduce the axis of this figure. The vertical axis is the phenological timing advancing rate, and the horizontal axis is the last spring frost data advancing rate. And the black line in the middle shows the y equals x line. For the dots above this line are the species, the responsive species whose phenology advanced faster than last spring frost data. As shown in this figure, most of the red dots are above the y equals x line. And this indicates that the phenological responsive species were more prone to increase the probability of frost damage, while the blue line are mainly below this y equals line. And that means the less sensitive species tend to have decreased frost damage. And similar trends were found for the temporal changes in the severity of spring frost damage. This is the analysis at the species level. As we referred earlier, the global warming was not equal across geographical regions. We also checked the geographical pattern in the probability and the severity of frost damage. This figure shows one example for Aesculus. Other species also show the similar trend. As showing these two figures, in the low latitude areas, such as the maritime and coastal areas, the frost damage tend to increase, as shown by the red dots. And in the continental high latitude area, showing as the green dots, this part tends to have decreased frost damage. Conclusion: warming tend to advance both phenology and last spring frost date, but the changes of the frost damage tend to depend on the responses of species and the geographical regions. And such difference among species may cause different changes in the species fitness. And the difference among geographical regions may cause the changes in the tree species distribution. And this is all for my presentation today. Thanks for giving me this opportunity to present our work.